There are several ways to find the intersection values of two polynomial equations, but one of the ways is to set the two equations equal to each other. When a polynomial equation is set equal to another polynomial equation, one gets an equation in which two polynomials are set equal. So some examples of what this would look like are x squared equals 8x, x cubed plus 2x squared equals x plus 2, and these are equations in which one side equals the other. We would first make each equation above equal to 0. So let's see what that would look like. The first example here would be x squared minus 8x equals 0. And the other one would be x cubed plus 2x squared minus x minus 2 equals 0. Then, since they both are equal to 0, then we can set them equal to each other. So then we would have x squared minus 8x is equal to x to the third plus 2x squared minus x minus 2. To solve such equations algebraically by factoring or other algebraic techniques, we could find the zeros of these polynomials. We'll focus on finding the solutions using the zero product method. That's what we've been doing this whole time. But you can also do this algebraically. The x values for which a function f of x has a value of 0 is the same as saying f of x equals 0. These x values are called the zeros of the function, and these x values are also referred to as roots of the equation. We will consider only the real number zeros of the functions as we move forward. We'll just talk about complex conjugates and complex numbers toward the end of the quarter. Let's look at an example. If we want to find out where the intersection is between f of x and g of x, we would simply set them equal to each other. 1/3 x to the third minus 4x squared plus 10 is equal to negative 2x squared minus 2x plus 11. Now just set it equal to 0, so add 2x squared to both sides. Add 2x to both sides. And subtract 11 from both sides. This will give me 1/3 x to the third minus 2x squared minus 1 plus 2x equals 0. And I'm going to rearrange these. Plus 2x minus 1. Now go ahead and take a minute and graph this. The points at which your function cross the x-axis are the points at which the x values would define the intersection of f of x with g of x. What I'd like you to do is graph f of x and graph g of x. Then look at what the intersection points are. You'll find that when you set this equal to 0 and then say y is equal to this and find the intersections along the x-axis, the x values will match.